Chapter 6.3, Adding and Subtracting Rational Expressions. To add or subtract rational expressions, use the following steps. Step 1, factor the numerator and denominator if possible. Step 2, find the lowest common denominator. Step 3, state the NPVs. Step 4, add or subtract the numerators and write over common denominator. And simplify. And step 5, factor if possible and reduce. First set of examples, adding and subtracting with a common denominator, m over n minus m plus 1 over n. Step 1, factor numerator and denominator if possible. There's no factoring to be done here. Step 2, find the lowest common denominator. Lowest common denominator is n. They both have n. Step 3, state the NPVs. We have n as a denominator, so n equals to 0 is a non-permissible value. Step 4, add, subtract numerators, write over common denominator, and simplify. So m minus bracket m plus 1 over n. We need the brackets around the m plus 1 because that negative has to apply to both m and 1. We want to simplify, multiply the negative into the brackets. We get m minus 1 over n, which equals m minus m is 0, so we have negative 1 over n. Step 5, factor if possible and reduce. We can't factor, so there's our answer, negative 1 over n. 10m minus 1 over 4m minus 3 minus 8 minus 2m over 4m minus 3. Step 1, factor if possible. We can factor the second numerator, 10m minus 1 over 4m minus 3 minus, we can factor out a 2, 4 minus m over 4m minus 3. Step 2, our lowest common denominator. They're both over 4m minus 3. Step 3, our NPVs. We have 4m minus 3 as a denominator. That can't equal to 0. So 4m equals 3 and m equals 3 over 4 is our non-permissible value. Step 4, we want to write them in one fraction. We have a common denominator already, so 10m minus 1 minus 2 times 4 minus m over 4m minus 3. We're going to simplify, multiply the negative 2 into the brackets. We get 10m minus 1. Multiply the negative 2 in, negative 8 plus 2m over 4m minus 3. Combine like terms in our numerator. 10m plus 2m is 12m. Negative 1, negative 8 is negative 9 over 4m minus 3. Step 5, factor if possible and reduce. 12m minus 9, we can factor out 3. 3 times 4m minus 3 over 4m minus 3. And then we can divide out our common factor of 4m minus 3, and we get the answer of 3. Step 1, factor if possible. We can factor our first numerator, take out an x. We get 2x plus 1 over x plus 1, x minus 3. We can factor our second numerator, common factor of 3. We get 1 minus 2x, and over x minus 3, x plus 1. Our last one cannot be factored. 8 over x minus 3, x plus 1. Step 2, our lowest common denominator. Again, this one already has the lowest common denominator for all three, so x plus 1, x minus 3. Step 3, our NPVs. Our denominator is x plus 1, x minus 3. When is that equal to 0? Well, when this is equal to 0, which is when x is negative 1, or when this is equal to 0, which is when x equals 3, negative 1 and 3. Step 4, we want to write these over in one fraction. We already have a common denominator, so we can just combine them. X times 2x plus 1 plus 3 times 1 minus 2x minus 8 all over x plus 1, x minus 3. Then we want to simplify. We can multiply the x back into the brackets and the 3 back into the brackets. And you might be wondering, what's the point of doing step 1 and factoring if we're going to multiply back in step 4? But sometimes in step 1, we can actually reduce some of our fractions. This would be helpful if we don't have common denominators already, and we can take out one of the factors that would have been needed in our common denominator otherwise. So let's simplify this. 2x squared plus x plus 3 minus 6x minus 8 over x plus 1, x minus 3. Combine our like terms. 2x squared, x and negative 6x is negative 5x, and then 3 and negative 8 is negative 5 over x plus 1, x minus 3. Step 5 is to factor. So can we factor 2x squared minus 5x minus 5? Well, it is a complex trinomial since we can't factor out the 2. So we would need to multiply 2 times negative 5, which is negative 10. And then we want two numbers that multiply to negative 10. Multiply to negative 10 and add to give us the b value, which is negative 5. Numbers that multiply to 10, 1 and 10, 2 and 5. One of them would have to be negative to multiply to a negative. If we had negative 1 and 10, those would add to positive 9. If we had negative 10 and 1, those would add to negative 9. If we had negative 2 and 5, those would add to 3. And if we had negative 5 and 2, those would add to negative 3. None of those work, so it's not factorable, which means our final answer is 2x squared minus 5x minus 5 over x plus 1, x minus 3. Adding and subtracting without a common denominator. Step 1, factor if possible. There's nothing to factor here. Step 2, our lowest common denominator. We have 5x and 2y, so we need both of those. 5x times 2y for our lowest common denominator. Step 3, do our NPVs for 5x times 2y. When is this equal to 0? When x equals 0 or when y equals 0. Step 4, we want to do the adding and subtracting and write over the common denominator. The first fraction, 2x plus 1 over 5x, we need to multiply top and bottom by 2y to get the common denominator. 2y times 2x plus 1 over 2y times 5x plus Second fraction, 3x over 2y, we need to multiply by 5x, top and bottom, to get the common denominator. 3x times 5x over 2y times 5x. We can now write this in one fraction. 2y times 2x plus 1 plus 3x times 5x is 15x over 2y times 5x is 10xy. And let's continue to simplify. 2y multiplied into our binomial is 4xy. 2y times 1 is 2y plus 15, this should be x squared over 10xy. And then step number 5 would be to factor if possible. I'm going to write this with the x squared term first. 15x squared plus 4xy plus 2y over 10xy. We don't have any common factors. 15, 4, 2, there's no common factors there. X squared, xy, and y, there's no common variables. So we can't factor out a common factor. We also can't factor this as a trinomial because we have x squared and then xy and then y. Sometimes we do have two variables in a trinomial and we can sometimes factor them, but we would have to have x squared, xy like we have, but then we'd have to have a squared on that y. And then the numbers would also have to be factorable. So this is not factorable, which means this is our final answer. Three over m plus 2 over m plus 1. Step 1, factor. We can't factor anything. Step 2, what is our lowest common denominator? We have m and m plus 1 as our denominators. So m times m plus 1 would be our lowest common denominator. Step 3, NPVs, our lowest common denominator, m times m plus 1. When is that equal to 0? When m equals 0 or when m plus 1 equals 0, which is when m equals negative 1. So 0 and negative 1. Step 4, let's write these fractions with a common denominator. First one, 3 over m, we need to multiply by m plus 1. So 3m plus 1 over m times m plus 1. Second fraction, we need to multiply by m, 2m over m times m plus 1. Now we can write them in one fraction. We get 3 times m plus 1 plus 2m over m times m plus 1. And we can simplify, so multiply this 3 into the brackets. We get 3m plus 3 plus 2m over m times m plus 1. And combine like terms, 3m plus 2m is 5m plus 3 over m times m plus 1. And then step 5, can we factor this at all? No. 5m plus 3, there's no common factor. So this is our final answer. (5 over 2x minus 10 minus 4 over 3x minus 5). Step 1, factor. We can factor our denominators here. 5 over 2 times x minus 5 minus 4 over 3 times x minus 5. So we took out common factor of 2 and then a common factor of 3. Step number 2, lowest common denominator. We have 2 times x minus 5 and 3 times x minus 5. So our x minus 5 is the same. We need to make the numbers the same in the fraction for the lowest common denominator. So lowest common multiple of 2 and 3 is 6. So we're just multiplying 2 times 3 times x minus 5. Step 3, NPVs. When is 2 times 3 times x minus 5 equal to 0? When x minus 5 equals to 0, which is when x equals to 5. Step 4, we need to multiply the first fraction by 3. 5 times 3 over 3 times 2 times x minus 5. Second fraction, we need to multiply by 2. 4 times 2 over 2 times 3 times x minus 5. We can then write these in one fraction. We have 15 minus 8 over 6 times x minus 5. 15 minus 8 is 7 over 6 times x minus 5. Step 5, can we factor this at all? No. Can we reduce it at all? No. 6 and 7 cannot be simplified. So this is our final answer. Four over p squared minus 1 plus 3 over p plus 1. Step 1, factor. We can factor this denominator. It's a difference of squares, so p minus 1, p plus 1, plus 3 over p plus 1. Step 2, our lowest common denominator. Well, we have p plus 1. The left denominator has p minus 1, so p minus 1 times p plus 1. Step 3, our NPVs. When is p minus 1 times p plus 1 equal to 0? When p equals 1 or when p equals negative 1. Step 4, let's write these with common denominators and then combine them. First fraction already has the common denominator. I don't need to do anything. P minus 1, P plus 1. Second fraction, I need to multiply top and bottom by P minus 1. 3 times P minus 1 over P minus 1, P plus 1. I can write them in one fraction now. 4 plus 3 times P minus 1 over p minus 1, p plus 1. Can simplify this. 4 plus, multiply the 3 into the brackets. We get 3p minus 3 over p minus 1, p plus 1. And then we have 3p plus 1, negative 3 plus 4 over p minus 1, p plus 1. And then is the top factorable? No, we can't factor 3 plus 1, so we can't reduce at all. This would be our final answer. X minus 1 over x squared plus x minus 6 minus x minus 2 over x squared plus 4x plus 3. Let's start with factoring. X minus 1 over x squared plus x minus 6. It's a basic trinomial, two numbers that multiply to negative 6 and add to 1. That would be x plus 3 and x minus 2. Multiply to negative 6, add to positive 1. Minus x minus 2 on top. X squared plus 4x plus 3, another basic trinomial, two numbers that multiply to 3 and add to 4, x plus 3, x plus 1. Step 2, lowest common denominator. We have x plus 3x minus 2, and then x plus 3x plus 1. So we need each of those factors one time. X plus 3 is already there in both. We also need x minus 2 in both, and we need x plus 1 in both. Step 3, NPVs. When is our lowest common denominator? X plus 3, x minus 2, x plus 1 equal to 0. When this is equal to 0, which is x equals negative 3. When this is equal to 0, which is x equals 2. Or when this is equal to 0, which is x equals negative 1. So negative 3, negative 1, and 2 are the NPVs. Step 4, let's write common denominators and then put it into one fraction. X minus 1 over x plus 3, x minus 2. We need to multiply this fraction by x plus 1. So x minus 1, x plus 1 over x plus 3, x minus 2, x plus 1. Second fraction, x minus 2 over x plus 3, x plus 1. We're missing the x minus 2 factor, so we need to multiply that to top and bottom. X minus 2 times x minus 2 over x plus 3, x minus 2, x plus 1. Write this in one fraction. X plus 1 times x plus 1 minus x minus 2 times x minus 2. Ooh, one of these is a minus. X minus 1 times x plus 1. And then over x plus 3, x minus 2, x plus 1. Let's simplify. We want to multiply our binomials together. X minus 1 times x plus 1. X times x is x squared. X times 1 is x. Negative 1 times x is negative x. And then negative 1 times 1 is negative 1. And then we have minus. We want to multiply the next two binomials together. X minus 2 times x minus 2. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. We have this section in brackets because we have this negative, and we're going to have to multiply that negative into everything. So we need to keep those brackets for this one. Over our common denominator, x plus 3, x minus 2, x plus 1. We can simplify x and negative x. Those add to 0. We're left with x squared minus 1 minus brackets x squared negative 2x. Negative 2x is negative 4x, and then plus 4 over x plus 3, x minus 2, x plus 1. We can now multiply this negative into this bracket here. We get x squared minus 1 minus x squared plus 4x minus 4 over x plus 3, x minus 2, x plus 1. And then simplify x squared and negative x squared. Those add to 0. We have 4x, and then negative 1, negative 4 is negative 5 over x plus 3, x minus 2, x plus 1. Step 5, can we factor and reduce it all? 4x minus 5, there's no common factor, so we cannot. This is our final answer. Last example looks a little different but challenging. We have 2 minus 4 over y all over y minus 4 over y. So let's write that as division instead of in a fraction. 2 minus 4 over y in brackets, divide by brackets y minus 4 over y. Let's write the 2 and the y in fractions with the lowest common denominator. So we notice that we have 4 over y in each set of our brackets. So our lowest common denominator would be y in this case. Let's write 2 as a fraction over y. So we'd have to multiply top and bottom by y. We get 2y over y minus 4 over y in brackets divided by y times y would be y squared over y minus 4 over y in brackets. Now we can write each set of brackets as one fraction. So 2y minus 4 over y divided by y squared minus 4 over y. Now we can deal with the dividing of a fraction, which becomes multiplying by the reciprocal. 2y minus 4 over y times y over y squared minus 4. This denominator here is a difference of squares. So let's factor that. We get 2y minus 4 over y times y over y minus 2y plus 2. Now let's determine our NPVs. We need to look at the denominators of both of our fractions, but we also need to look at the numerator of our second fraction because we were dividing by that, so we ended up multiplying by the reciprocal. So at one time, that numerator was a denominator. So both the denominator of the first one and the numerator of the second one are y. So we have y equal to 0 when y equals 0. And then our second fraction, we have y minus 2 times y plus 2 equals to 0. When does that happen? Well, here when y equals to 2, and here when y equals to negative 2. Then we have negative 2, 0, and 2 for our NPVs. Next, let's multiply our fractions together. We have y times 2y minus 4 over y times y minus 2 y plus 2, and we can divide out the y's. We're left with 2y minus 4, which we can factor out the 2. So 2 times y minus 2 over y minus 2 y plus 2. And then we notice we have y minus 2 on top and bottom, so we can divide those out as well. And we are left with 2 over y plus 2. That brings us to the end of Chapter 6, Lesson 3.